All right, so this is on your titration lab write-up that we completed in class yesterday. This is an example problem, and I just wanted to go over with you so that today you can work on your titration lab calculations, and then you can work on your actual CER and that kind of stuff. So you want to remember that you want to be neat in your lab because you do get points for how you present your materials. So you want to make sure your calculations are complete. You want to make sure your calculations are clear. So if you look in your paper, what we have here is that you have an example titration problem right before you get to the actual procedure. So it says there was a titration between an unknown molarity of a sulfuric acid and there was 15 mils of this magnesium hydroxide used. And we want to determine the molarity of the sulfuric acid. And I apologize because this somehow I deleted it before I printed the paper out. But the sulfuric acid is a 20 mil sample. So that's how much of the acid we started with. In the lab we did yesterday, you guys were starting with like 10 to 15 mil samples of hydrochloric. But it's the same idea. So whenever you do a titration problem, the first thing you want to do is write and balance the equation. So you want to remember we have sulfuric acid with magnesium hydroxide. It's a double replacement. So hydrogen and magnesium switch. Magnesium ends up with sulfate. And if you remember from your charges, it might be good to start reviewing them. Magnesium is +2, sulfate is -2. And then we get hydrogen with hydroxide. And if you remember, we commonly write them as water. So we get H2O, and then you balance it. So you have to do that first. So today when you do your calculations, write the balance equation first. Step 2 is you need to figure out how many moles of the known chemical you have. So in this case, it's magnesium hydroxide. For the actual lab calculations, it's going to be sodium hydroxide because that's what we actually did in the lab. So we're going to use our molarity equation, and they gave us our molarity, so that's the 0.45 right here. And then you have to remember that it's moles per liter, so you have to take your milliliters, which we generally use, and turn it into liters. So to do that, remember you're dividing by 1,000. So 15 divided by 1,000 is 0.01500 liters. And then you just algebraically solve for x, so multiply both sides by 0.0150, and you get your moles of your magnesium hydroxide. So remember, the whole point of a titration is that you get at the equivalence point, where your moles of your magnesium hydroxide stoichiometrically match the moles of your acid. So what you have to do for your third step is you have to use your balanced chemical equation to do a mole ratio. So a lot of times it's a 1-to-1 mole ratio, but it is not always, which is why you have to write the formula out and balance it. So you'll see here we took our moles of magnesium hydroxide, and then what I did is I looked at my reaction and saw, okay, there's 1 mole of magnesium hydroxide. That goes on the bottom. And when I looked at my sulfuric acid, there's 1 mole of that. So that went on the top. My magnesium hydroxides went away, and I got my moles of my acid. So it's 0.0068 moles sulfuric acid. So the very last one down here, step number 4, determine the unknown molarity of your chemical. I actually did it up here just to make it fit. And what I did is I took my moles of my acid, 0.0068, and I divided it by the volume of the acid sample. So when in this case, you guys will have that. Like I said, I accidentally deleted it from the problem, so I apologize. So I took my 0.0068 moles, and I divided by my 0.0200 liters of it, and I got my unknown molarity. So what you want to do is calculate those today, and then when I see you guys on Friday, I can give you the real one, and you can see if they match or not. One thing you want to remember when you're looking at your volumes, a good question is, well, what volume do I use? How do I know if it's 15 mils or 20 mils or whatever? For each of your titrations, you want to use the amount used. You don't want to use your initial. You don't want to use your final. You're going to subtract those two. And then when you do final minus initial, then you want to have the volume used. So hydrochloric acid used, sodium hydroxide used in your calculations. Hopefully this helps you so that you can do the calculations and get working on your CER. Remember, this is an individual assignment. So you have the same data as your group, but you need to do this on your own.